Mr. Klein here from SQA Maths. Today we're going to do the Advanced Higher Maths 2024 Paper 2. SQA Advanced Higher Maths 2024 Paper 2 Question 1. Given the y equals 7 sine 7x over 1 plus x squared, find the y by dx. So we're going to use the quotient rule. So we've got the y by dx is equal to v, 1 plus x squared, u dash, sine becomes cos. So it's 7 cos 7x, v u dash minus u sine 7x, v dash, well that's just times 2x, all over v squared, which is 1 plus x squared, all squared. Tidy that up a little bit, but it is only worth 2 marks. So I've got 7, 1 plus x squared cos 7x, minus 2x sine 7x, all over 1 plus x squared and squared. And let's see if we can do anything else with that. I'm happy to leave it like that, so I'm done there. SQA Advanced Higher Maths 2024 Paper 1 Question 2. Use a Euclidean algorithm to find a and b such that 533a plus 455b equals 13. So we're just dividing over and over again. So we've got 533 equals, well, obviously 1 times 455. And then we need to find the remainder. So you're going to use a calculator anytime you want, but I've already done this. And you get 78 just by taking away. So then you start again with 455. And we're going to divide by 78. 578 is the answer. And then you get 65 left over. Again, you're just using a calculator. So then 78 we're going with, divided by 65. So that's 165s obviously. And the remainder when you do that is 13. And then finally, 65 is 5 13s, and you get plus 0. And now we just kind of work backwards from this point, rearranging as we go. So I've got 13 is equal to 78 minus 1 times 65. So that's using from here. So then we can go back a step further. That equals 78 still. And then rearranging this line for 65, you get minus 1 times, so minus 455 minus 5 times 78. And then we can go further than that by expanding that bracket. That's 78 minus 455, and then it's minus times a minus is a plus, so plus 5 78s. So that is 6 78, 6 times 78. Minus 455, and then we go up again. So we've done that. So then 78 is 533 minus 455. So that's 6 lots of 533 minus 455. And we've still got 455 on the end. So that's 6 times 533 minus 6 times 455 minus 455, 6 times 533 minus 7 times 455 is equal to 13. And that's what we want, 533 and 455. So just to answer the question, A equals 6 and B equals negative 7. And we're done there. To Advanced Higher Maths 2024 Paper 2 Question 3. Use Gaussian elimination to express Z in terms of lambda for the system of equations. Find lambda for when it's inconsistent, and then determine the solution of the system when lambda is negative 1. So Gaussian elimination, I've got 1 minus 3 equals 1. 2 minus 3 minus 5 is 8. And 1, 2 lambda is negative 7. I'll usually put a wee dotted line on there. So there is my matrix. And what I've done is I've said that row 2 is going to become row 2 minus 2 row 1. And simultaneously, I'm going to have row 3 becoming row 3 minus row 1, just to get my zeros in the left-hand side. So we've got 1 minus 3 and 1. And then you've got 2 minus 2 is 0, minus 3 plus 2 is minus 1, minus 5 plus 6 is 1, and 8 minus 2 is 6. And then 1 minus 1 is 0. 2 plus 1 is 3, lambda plus 3, and finally minus 7 minus 2 is minus 9. Minus 7 minus 1 is minus 8. Don't know why I said minus 2. Okay, so now we want a 0 on the bottom line, so we're going to go row 3 equals row 3 plus 3 row 2. So we've got 1 minus 1 minus 3, 1, 0 minus 1, 1 and 6, 0, 0, lambda plus 3 plus another 3 is lambda plus 6, and minus 8 plus 3 sixes is 18, gives you 10. So that means that this number times z is usually equal to 10. So we could say that lambda plus 6 times z equals 10. In other words, z is 10 over lambda plus 6. And we're done there for part A. Part B, state the value of lambda for which the system's inconsistent. Inconsistent. No work required for this when lambda equals negative 6, because you can't divide by a 0. Determine the solution of this system when lambda is negative 1. Okay, so we've got a bunch of equations. So lambda is negative 1, and we've got z equals 10 over lambda plus 6. That's 10 over minus 1 plus 6. That's 10 over 5, which is 2. So we know that z equals 2 is our first solution. Next equation, minus 1 minus 1 plus z is 6. So minus 1 plus 2. Next equation, minus y plus z equals 6. Minus y plus z equals 6. So that's minus y plus 2 equals 6. So minus y is 4. In other words, y is negative 4. And there's our y. Then the last equation, x minus y minus 3z is 1. X minus y minus 3z equals 1. So we've got x plus 4, because minus minus. 3 2's is 6, minus 6 equals 1. So x minus 2 is 1, and x must be 3 then. So we've got x, y, z, so we're done there, and I'm happy with that. 3, minus 4, and 2. SQA Advanced Higher Maths 2024, Paper 2, Question 4. Solve this differential equation. So it's a second order. D square y minus 2 minus 8y is 0. So yep, and we can just use the auxiliary equation then. And we're given some information, but let's just start there. M squared minus 2m minus 8 is 0. Quick factorisation on that to give us m and m. 4 and 2. Minus 4 plus 2. So m is minus 2 and m is 4. So that means that our general solution is y equals a e to the, we'll just put the positive one first, 4x, plus b e to the minus 2x. Doesn't really matter the order you put them in. But then we can find our particular integral by substituting in our initial conditions. So when y equals minus 2, x is 0. So that gives us minus 2. E to the power of 0 is 1, so that's a plus b. And then differentiating it, the y by dx is equal to 4a e to the 4x minus 2b e to the minus 2x. So it says 22. So 22 equals 4a minus 2b. So you've got two equations. Let's just solve them simultaneously. We'll put them one above the other. So I'll just times the top one by 2. So that's going to give me 2a, 2b minus 4, 4a minus 2b, 22. Adding them together, you get 6a is equal to 18. So a equals 3. And that implies that b must equal minus 2 minus 3 is minus 5. So we get 3 and minus 5. Now to get our answer then, y just equals, remember it was a to the 4x plus b to the minus 2x, 3e to the 4x plus b minus 5 e to the minus 2x. That's our particular integral, and we're done there. Advanced Higher Maths 2024, Paper 2, Question 5. State and simplify the general term of the binomial expansion of this, and then find the coefficient of 1 over x to the 18. So start of the exam paper tells you that n choose r, what's the sum of, but we're just wanting the general term, a to the n minus r. b to the r. So r in this case is 16, okay? And what's our a and b? Well, a is just 2x squared, of course. B is minus 1 over x cubed. And we can say that n is equal to 16. Now I might as well just change that to minus x to the minus 3 straight away for my substitution. So we've got 16 choose r, 2x squared, 16 minus r, minus x to the minus 3 r. And then we need to just collect the terms in terms of x's and numbers basically. So you've got 16 choose r, you've got 2 to the 16 minus r, x squared to the 16 minus r. So the minus x you can think of as being minus 1 to the r, and then this leaves you with x to the minus 3, so minus 3r. So that's 16 choose r, 2 to the 16 minus r, minus 1 to the r, x to the 2 16s is 32, minus 2r, and then x to the minus 3r, and finally we get 16 choose r, 2 to the 16 minus r, minus 1 to the r, x to the 32 minus 5r, and we're done there. So I find the coefficient of 1 over x to the 18. Over x to the 18 is x to the minus 18. That implies 32 minus 5r is minus 18. So minus 5r is minus 32 minus 42 minus 50. So r is 10. And now we know that. It is easy. We get 16 choose 10. 2 to the power of 16 minus 10 is 6. Minus 1 to the power of 10. And it's just a coefficient, so we don't need to write anything to do with x. It's just a coefficient. 16 choose 10 times 2 to the power of 6. And minus 1 to the power of 10 is 1. So that's just 512, 512, and we're done there. SQA Advanced Higher Maths, 2024, Paper 2, Question 6. Our coverage is defined parametrically by x equals t squared and y equals 4t log t, where t is greater than 0. If we simplify the expressions for dy by dx and d2y by dx squared, let's just start with the first one, a, dy by dx, dy by dt, dt by dx. So I need to work out those things. So dy by dt, where are we? Where we are there. So it's a product, so it's v, u dash, so that's log t, and u dash is 4, plus u, v dash log t becomes over t. Simplify that, we get 4 log t plus t, plus 4 even, what on the day I am. 4 log t plus 4. Now we could simplify that further by putting it in brackets, but I'll leave it like that for now in case I need it outside. I'll put it back in later. So now I'll just do my dx by dt to get my dt by dx. dx by dt is just 2t. So now I can work out my dy by dx. I've got 4 log t plus 4. And it's times by dt by dx. So it's divided by 2t times 1 over 2t. So now we can just divide through by 2 to get 2 log t plus 2 over t, which is 2 log t plus 1 all over t. And I don't think I'm going to simplify it any further than that. Part B, d2y by dx squared. Well, I've got dy by dx, let's put that up here, in terms of t. So you're going to do d by dt of the y by dx, but then I'm going to have to eliminate that t, so times the t and then by dx. Why dx? Because I want d2x, so there you are. So that is the second derivative. So I'm going to use the product quotient rule, so v times u dash, so 2 log t goes to 1 over t, so that's 2 over t, and plus 2 goes to nothing. So vu dash minus u v dash is 1, all over v squared, which is t squared, and now I need to times by dt by dx, if I can remember what it is. dx by dt is 2t, so dt by dx is 1 over 2t. So that's what we need to do, and then we need to somehow simplify this. Well, let's hope it's nice. So that gives me t over t is 1, so that's 2. Watch for your signs here. Minus 2 log t, and it's minus 2. All over t squared times t is t cubed, 2t cubed. So obviously you can see the 2's cancel. So that gives me, dividing through by 2, they're gone. 2 divided by 2 is 1, so minus log t over t cubed. And I think I'll leave it like that. And I'm done there. SQA Advanced Higher Maths 2024, Paper 2, Question 7. Find and simplify the Maclaurin expansion up to including the x cubed term for e to the 2x, sine 3x, and then you have to do something together with that. So let's just do part 1 first. Now you might have memorised e to the x already, but if not, just start from the start. So we've got f of x is f of 0 plus f dash 0x plus f double dash 0x squared over 2 factorial, of course, plus triple x cubed over 3 factorial, and you could go on like this forever. So we've got e to the 2x, that's f of x. So f of 0 is equal to just 1. F dash x is 2e to the 2x, so f dash 0 is 2. F double dash then is 4e to the 2x, so f double dash is 4, and so on. You'll get 8 again, but we'll just see. So f triple dash 0 is 8. So we can say that f of x is equal to 1 plus 2x plus 4x squared over 2 plus 8x cubed over 3 factorial, which is 3 times 2 is 6, plus blah blah blah. We've only got the x cubed. 1 plus 2x plus 2x squared. Divide by 2 to get 4x cubed over 3. And they're done there. This is sine 3x. Again, you might have memorised sine x and just put 3x in, but if not, just start from the beginning. It doesn't take too long. Sine of 0 is 0. That's good. G dash x, 3 cos 3x. So g dash 0 is, cos of 0 is 1, so that's just 3. G double dash is going to oscillate. We're going to go back to sine. That's going to be minus 9 sine 3x, which means g double dash 0 is still 0. And the triple dash is minus 27 cos 3x. So g triple dash 0 is minus 27. So now we can sub in, we can say that g of x equals g of 0, which is 0, plus, remember it's up here, g dash 0x, so that's 3x plus 0, that's x squared, and then the x cubed minus 27 x cubed over 3 factorial, which is 6. Simplifying that off, we get 3x, 27 and 6, 3 goes into both of them by 9, x cubed over 2. Oh, I'm happy with that. Part B says, hence find the Maclaurin expansion up for e to the 2 sine 3x up to the x cubed term. Okay, so e to the 2 sine 3x, and we've just done e to the 2x, and we've done sine 3x. So that's appearing in there. So if I expand this out, e squared sine 3x, we already know. 3x is this up here, 3x minus 9x cubed over 2. That's it as a Maclaurin. So then it says e to the power 2 of that. Well, imagine that as like a variable x or y. we know e to the 2x from up here, so we can just use that. 1 plus 2x plus 2x squared plus 4x cubed over 3. So that gives me 1 plus 2x, but this is now my x, so 3x minus 9x cubed over 2 plus 2x squared, 3x minus 9x cubed over 2 squared, and 4x cubed over 3, 3x minus 9x cubed over 2 to the 3, and it's over 4 over 3, isn't it? 4 thirds. So then we'll just try and expand and simplify that. Now remember, you only need to go up to x cubed, so you can know a lot of them. So that gives me 1 plus 6x. 2's cancel, so minus 9x cubed. So I've done that line. Next line, 2. I'll have 3x times 3x is 9x squared. Timesing these together, 3 times 9 is 27, over 2 times 2 is 27, so minus 27 x to the 4, which you can just ignore, and then minus, I'll just put 9 over 2 x cubed squared, because you can just ignore that one anyway, and you can ignore that one, so that gives you that to expand, plus 4 thirds, and then you're cubing everything, so you get cubed, and then you get squared, squared, cubed again. So the 3x cubed is going to come in. But then what you'll have is, you will have a term here squared times a term here. And that's always going to be too big. And similarly, when you do that times that, that'll be too big. And then the final answer will be too big. So you can just ignore the rest. And if you don't realise that, just write it out. So that gives me 1 plus 6x minus 9x cubed. 2 9s is 18x squared. And 3x cubed, I'll just do this at the side, is 27x cubed. So 27 divided by 3 is 9. 9 4s is 36. So plus 36 x cubed. So then simplifying that a little bit with x cubed, you get 1 plus 6x plus 18x squared. 36 minus 9 is 27 plus 27x cubed. And there would be other terms, but we'll just not work them out. And we're done there. SQA Advanced Higher Maths 2024, paper 2, question 8. A solid is formed by rotating part of a curve with equation y equals 1 over the square root of 1 plus x squared about the x-axis through 2 pi radians from 0 to x equals a. And the value of the volume is pi squared over 3, find a. So the volume is v equals the integral of pi times y squared dx. And we have got between 0 and a. And that equals, just to remind us, pi squared over 3. So as long as you know that, this question should be reasonably straightforward. So that's pi times, well, if you the integral of 0 to a, y squared, let's have a look, 1 over square root of 1 plus x squared, 1 plus x squared dx equals pi squared over 3. So check that example for that one. I think that's the inverse tan. So that becomes pi times the inverse tan of x between 0 and a equals pi squared over 3. So that's pi times the inverse tan of a minus the inverse tan of 0 equals pi squared over 3. So you can eliminate a pi for both sides then, and the inverse tan of a we get on this side minus the inverse tan of 0 is 0. That's not times by pi anymore because I'm just going to say that's pi over 3, just to eliminate a pi for both sides. So that means the inverse tan of a is pi over 3. So that means that I can just kind of work that out. If I draw an exact value triangle, I'm just going to think in degrees and then change it back. 2, 1, root 3. If the inverse tan of a is pi over 3, that means a must have been 60 root 3. And we're done there. SQA Advanced Higher Maths 2024, Paper 2, Question 9. An arithmetic sequence has the first term minus 3 and a common difference of d. State an expression for the third term. That should be quite easy to start with. So we've got un is equal to a plus n minus 1d for an arithmetic sequence. So the first term is minus 3. So un equals minus 3 plus n minus 1d. And we want the third term. So u3 equals minus 3 plus, well, 3 minus 1 is 2, 2d. So that's part A. Part B says the 8th term is 5 times the third term. So u8 equals 5u3. But we can also write an expression for u8. u8 equals minus 3 plus n minus 1, 7d. So we've got one expression, but we could also use this one, 5 times minus 3 plus 2d. So expanding that out, u8 must equal minus 15 plus 10d. So we've got two expressions for u8, so we can just make them equal to each other to get d. So taking this d's over here, we get 3d, 15 over there to get 12, and d must be 4, and we're done there. Term and algebraically, the least number of terms required so the sum of the associated series is greater than 500. So for 9c, using the start of the exam paper, Sn equals a half n 2a plus n minus 1d. We're saying that that's greater than 500. So we've got a half n, 2a is minus 6 because it's 3, plus n minus 1 times d, and we just worked out d was 4. So that's greater than 500. So we can just keep going. A half n minus 6 plus 4n minus 4 is greater than 500. A half n minus 10 plus 4n is greater than 500. Expanding the bracket out then, a half of 10 is 5, so it's minus 5n. A half of 4 is 2, so it's plus 2n squared is greater than 500. So a quadratic inequality. We get 2n squared minus 5n minus 500 is greater than 0. So we can examine the roots. Now that won't factorise, so there's a, there's b, and there's c. And we'll use the quadratic formula. So x, or in this case n, equals minus b plus or minus the square root of b squared minus 4ac over 2a. So just being careful, we get 5 plus or minus the square root of 25. 4 times 500 is 2,000, times 2 is 4,000, and it's plus because it is minus minus. So that's 5 plus or minus the square root of 4,025 over 4. And you'll just need to get a calculator for that one. So 5 plus root 4025 divided by 4 is 17.1, or 5 minus root 4025 over 4 is minus 14.6. Now let me just draw a graph for this. We want it to be greater than 0. So we've got 17.1 over here, and we've got minus 14.6 over there. So you can see if it's greater than 0, either less than minus 14.6 or greater than 17.1. But we can eliminate this one because n has to be bigger than 0. The solution is n is greater than, strictly greater than, or equal to 18. Or you could say that n is greater than 17 if you prefer. So to answer the question, determine algebraically the least number of terms required so that the sum of associated series is greater than 500. Least number of terms is 18. It's not 17. And we're done there. SQA Advanced Higher Maths 2024, Paper 2, Question 10. A metal rod is heated such that its volume increases at a constant rate of 12 millimeters cubed per minute. The volume of the rod is modelled throughout the process by V equals 5 pi r cubed, where r is measured in millimetres. Find the rate at which r is increasing when r is 10. Okay, so we want the rate dr by dt in the end, but we know at the moment metal rod is heated, so its volume increases at a rate, so dv by dt, we already know, equals 12. And we already know that v equals 5 pi r cubed. So we can work out dv by dr, but we actually want to know dr by dt. But let me do dv by dr, because you can do that. dv by dr is equal to 15 pi r squared. And then using the rules, dv by dt equals 12, but dv by dt is dv by dr times, then there we are, dr by dt. So we can rearrange for dr by dt in a moment, but dv by dt is 12. That equals 15 pi r squared times dr by dt. In other words, dr by dt is 12 over 15 pi r squared. So we have to do that at r equals 10. So when r equals 10, dr by dt is 12 over 15 pi times 10 squared. That equals 12 over 10 tens are 100. 100 times 15 is 1500. 1500 pi. You can simplify that if you want. 12 into 12 goes 1. 12 into 15 goes 1. 12 twos are 24. 12 fives are 60. 1 over 125 pi in the units are millimetres per minute. So it would be millimetres per minute. Or you can put that all in a calculator and you get about 0.0025 millimetres per min. And you probably would have done that, so I'll put that there for reference. SQA Advanced Higher Maths 2024, Paper 2, Question 11. Consider statements A and B below. For each statement, if true, provide a proof, and if false, provide a counterexample. Okay, statement A. The sum of the squares of any two consecutive numbers is always prime. I'm thinking Pythagoras here. 3 squared plus 4 squared equals 25. Well, 25 is not prime. There you go, counterexample, job done. 3 squared plus 4 squared equals 9 plus 16 plus, which equals 25. 25 is not prime, therefore it's false. I'm sure there's other examples, but that one will do. Okay, the sum of any two consecutive integers is always odd. Let's see if that is true by saying that, look, let's let n be an integer, and then the next one is n plus 1 then. So you're going to have n squared plus n plus 1 squared. And just a reminder, looking at odd, the form you're looking for is 2a plus 1 is odd, or 2n plus 1, whatever. Expand the bracket, we get n squared plus 2n plus 1, which is 2n squared plus 2n plus 1. So taking out a common factor with 2 from the front bit and the n, or just 2 even, we'll get n squared plus n plus 1, and that's just a number. So that's just basically of the form 2a plus 1. So we can just immediately say that equals or is of the form 2a plus 1, therefore odd. So statement true. And we're done there. SQA Advanced Higher Maths 2024, Paper 2, Question 12. Given that z equals x plus y, where y is not equal to 0, solve that equation. Where z bar is the complex conjugate of z. That's nice of them telling us. We should know this anyway. So we'll just sub it in and just solve. No big deal, surely. X plus iy squared plus 20x minus iy, because it's a complex conjugate, minus 156 equals 0. So let's just see where we get with this. X squared plus 2xyi plus I squared y squared plus 20x minus 20yi minus 156 equals 0. Let's collect all the real terms in the same bit together. So I've got x squared plus 2xyi minus y squared, because I squared is minus 1, plus 20x minus 20yi minus 156. And think of that, 0 is 0 real plus, well, 0 imaginary either. So 0 plus 0i, you can think of that as. So you can just say that the real part, so looking at the real part of this side, we've got x squared minus y squared plus 20x minus 156 equals 0. And then looking at the imaginary part, you've got 2xy, and then you've got minus 20y, and that equals 0. So we can just solve them simultaneously. So looking at the imaginary part, because that's a simple one to solve, 2xy equals 20y, so y's cancel, 2x equals 20, we've got x is 10 straight away. We know x is now 10, so we can just do 10 squared minus y squared plus 20 times 10 minus 156 equals 0. 100 minus y squared plus 200 minus 156 equals 0. So that's 300 minus 100 is 200 minus 56 is 144. So you get minus y squared plus 144 equals 0. You can solve that directly or with double brackets, it's your choice. I'll just do it directly. Y squared is 144. That implies y equals the root of 144, but plus and minus. So y equals 12, or y equals minus 12. Z is x plus iy. So Z1, first solution, x is 10, 10 plus 12i. And the second solution must be the complex conjugate, which it is 10 minus 12i. Two solutions for a quadratic, so we're done there. SQA Advanced Higher Maths 2024, paper 2, question 13. Quite a long one this. Express minus 2 over x plus 1 in partial fractions. So that's okay to start with. Minus 2 over x plus 1 just equals a over x plus b over x plus 1. So that means that ax plus 1 and bx equals negative 2. So when x equals 0, we get 0 plus 1 is 1, a equals minus 2. And then when x equals minus 1, that's 0, we get minus b equals minus 2, so b is equal to 2. So our partial fractions are a, which is minus 2, over x, plus b, which is 2 over x plus 1, or if you prefer, 2 over x plus 1 minus 2 over x, if you like the look of that better. Part B, use integration by parts to find the integral of x e to the 3x dx. So the integral of x e to the 3x dx, so we've got uv dash. So the one we want to disappear is x when we do u dash, so that's u and that's v dash. So that means that u dash is equal to 1 and v is the integral of e to the 3x, which is a third e to the 3x. And just a reminder of your formula, the integral of uv dash equals uv minus the integral of vu dash. So that gives us uv dash is uv, so x times a third, so a third x e to the 3x minus the integral of vu dash, well v is a third, so I'll take the third out, times the integral of e to the 3x, and u dash is 1. So you get it simplified to there quite quick. So that gives me a third x e to the 3x minus, we already know e to the 3x goes to a third e to the 3x, so that's going to be a ninth e to the 3x. And make sure you add a c. How simple you want to go with this is up to you. A nice thing to do, which I noticed someone else doing, was taking a ninth e to the 3x out instead of just a third. If you take a ninth out, you get a nice thing because you get 3 here times x, because 3 over 9 is a third, and then that only gives you 1, so minus 1 in the bracket plus c. So that's a nice way to leave it. Using your answers to A and B, solve this differential equation. Okay, so we've got a differential equation. I've written this here, and that is of the form dy by dx plus p of xy equals q of x. We were nasty q of x, but it does equal q of x. So our p of x in this case is minus 2 over x plus 1, which is handy because that was part A. And our q of x is x cubed e to the 3x over x plus 1 squared. Okay, so let's go for there. If you recall, a quick method for this is that you do the integrating factor times y equals the integral of the integrating factor times q of x dx. And so the problem I've got is I need to find my integrating factor. So my integrating factor, I of x, is e to the integral of p of x dx. So what is p of x? P of x is this, and the integral of p of x, well, we did that up here. Well, we've not, but we've expressed it in partial. This thing was expressed in partial fractions, so we can just write down 2 over x plus 1 minus 2 over x. So let's just do that here. The integral of p of x equals the integral of 2 over x plus 1 minus 2 over x dx. Well, that's just 2 log x plus 1 minus 2 log x. Well, that's just log x plus 1 squared over x. Our integrating factor is equal to e to the power of a log x plus 1 squared over x squared. E to the power of a log is just taking away the log, so you get x plus 1 squared over x squared. So there's our integrating factor. So now we can just write our integrating factor times y equals the integral of x plus 1 squared over x squared times x cubed e to the 3x, x cubed e to the 3x over x plus 1 squared. Try and cancel anything we can. So we've got x cubed and x squared. So I can do that and get x to the 1 and do that. You've got x plus 1 squared and x plus 1 squared, so you can just say goodbye to them. So that equals the integral of x e to the 3x. I should have a dx on it. So x plus 1 squared over x squared times y equals that. 1/9 e to the 3x, 3x minus 1 plus c. Make sure you get a plus c in there. So that equals that. So now we can rearrange for y. So y equals, dividing through by a fraction just times by the reciprocal, so I'll put the x squared on the top. So we've got x squared e to the 3x, 3x minus 1 over 9 x plus 1 squared. And then make sure that c becomes something as well, cx squared over x plus 1 squared. Make sure you do that for the c or you'll actually lose a mark. Would we want to simplify that? I think I can. That's factorised, that's factorised, that's factorised, that's factorised, nothing common to that. That's factorised. You know, I think I'd leave that there and say I'm done there. SQA Advanced Higher Maths 2024 Paper 2 Question 14. A plane passes through A, B and C. Determine A, B and AC. Part reason you through this one. A, B is like higher maths, B minus A. So that is, I'm not going to show the working for this, guys. 1 minus 2 is minus 1. 1 minus minus 1 is 2. Minus 1 minus 8 is minus 9. Okay, AC. C minus A. 4 minus 2 is 2. Minus 2 minus minus 1 is minus 1. 11 minus 8 is 3. So we get our two vectors there. Part 2. Hence, find the Cartesian equation of the plane. So we've got a plane. What's a plane? Where's a plane? We've got 3 points, A, some B and C. I don't know where they are, but this will do as a picture. So we've got two vectors like that. So we've got a normal to those points at A. So to work out that, it's the cross product. So we do AB cross AC. Now you can use that exam paper for this. It is a matrix, IGK, AB is minus 1, 2, minus 9, and AC is 2, minus 1, and 3. So using this that exam paper to help me, it's the determinant of 2 minus 9 minus 1, 3 times I minus the determinant of minus 1 minus 9, 2, 3 times J plus the determinant of minus 1, 2, 2 minus 1 times K. Our 2D determinants. 2 3s is 6, minus 1 times minus 9 is 9, so 6 minus 9 is minus 3. I. Minus 3, minus is plus 18, 18 minus 3 is 15, so it's minus 15J. And then we've got minus times minus a plus, so that's 1 minus 4. 1 minus 4 is minus 3. Okay, but any normal will do. So if I write that as minus 3 minus 15 minus 3, why don't I just take out minus a third as a common factor to get 1, 5, 1, because that's much nicer to work with. Just remembering that we then just do n dot r equals n dot a, b or c, doesn't matter what point you use. I think I'm going to use b because the numbers are easier, 1, 1 minus 1. So I'm just going to use that as my normal because why not, any normal will do. So I've got 1, 5, 1, x, y, z equals 1, 5, 1, and then the point I'm going to use is 1, 1 minus 1. So that gives me x plus 5y plus z equals, let's just work this bit out, 1 times 1 is 1, 5 times 5 is 5, 1 times minus 1 is minus 1, that just equals 5. And there's the equation of our plane. Part B, the line defined by these equations show that the line and plane don't intersect. Let me just copy these equations down to the rest of that page. Okay, I'm going to do this using parametric equations. That's the way I always do something like this. I'm going to let that equal, say, t, and then I get x minus 1 equals t, which implies x equals t plus 1. I get y plus 1 equals minus t, which implies y equals minus t minus 1. And I get z plus 1 equals 4t, which implies that z equals 4t minus 1. So I've got my equations of the line and the point, so I'll just sub them in and hopefully I'll get a contradiction if it doesn't work. That'll be inconsistent. So I've got subbing in, I get x, which is t plus 1, plus 5y, which is minus t minus 1, plus z, which is 4t minus 1, and that's meant to equal 5, but I'm not going to write equals 5. I'm just going to sub in to see the point of intersection. Well, that's meant to equal 5, yeah? So we get t plus 1, and we get minus 5t minus 5 plus 4t minus 1 equals 5. Plus 1 is 5t, minus 5t is 0. Then we've got 1 minus 1 is 0, so you get minus 5 equals 5. Well, minus 5 cannot equal 5, so therefore no point of intersection. And we're done there. SQA Advanced Higher Maths 2024, Paper 2, Question 15. A storage tank contains a mixture of salt and water. An additional amount of salt and water pours in while at the same time some of the existing mixture pours out. The process can be modelled by this first order separable differential equation where W can't be less than 36. W is the amount of salt in kilograms at time t minutes. Initially, the storage tank contains 8 kilos of salt. Express W in terms of t. Okay, part A. So I've got dW, 120 of that, equals 36 minus W times dt. So in other words, dW over 36 minus W equals dt over 120. Integrate both sides in. That's a log for this one, so it's the log of 36 minus W, but chain rule, remember, applies, so times minus 1. That equals, well, that's just 1 over 120. And we've got t. So it's t over 120 plus some constant, let's call that c. And therefore w equals minus e to the minus t over 120 plus d plus 36. So now we can separate our variables out, minus e to the minus t over 120 times e to the d plus 36. We'll just say that let a equal e to the d. So w equals minus a e to the minus t over 120 plus 36. I mean, initial conditions were that when t equals 0, w equals 8. So that means that 8 equals minus a plus 36. So a must equal 36 minus 8, 26, 27, 28. And therefore w equals minus 28 e to the minus t over 120 plus 36. And we're done there. Part B, find the rate at which the amount of salt is increasing after 67 minutes. So we want to know what the w by the t is at t equals 67. Two ways to do this. You could go back to your initial equation, and since you've already got w here, you could sub 67 in to get w, and then sub w into get into the w by dt. That's one way to go away, or a better way. Let's just work out dw in terms of t, dw by dt, using this formula. So we've got e to the minus t over 120. So that's still e to the minus t over 120. We've got minus 28, but that's going to be times by the derivative of t over 120 minus, which is just 1 over 120. So you'll get 28 over 120. And then you've still got plus 36, but that's gone. So at t equal to 67, dw by dt is 28 over 120 e to the minus 67 over 120. Doing that in a calculator then, e to the power of minus 67 over 120 is that, times 28 over 120 is 0.134. And the rate would be kilograms per minute. So we're done there. Part C. As the process continues, the amount of salt approaches a limit, L kilograms. Find the value of L. So W equals minus 28 e to the minus t over 120 plus 36. So we're wanting to know what happens as t goes to infinity. Well, w goes to minus 28 e to the minus infinity over 120, which is still minus infinity, plus 36. So we need to know what happens to e as it approaches negative infinity. Well, there's the graph of e. As that gets smaller and smaller, it gets closer and closer to 0. So we can say that w approaches 0 plus 36. So w approaches 36, which means our limit L is equal to 36 kilograms. And we're done there. After today, we went through the whole of SQA Advanced Higher Maths 2024 Paper 2. Next paper, the paper before this, is on your screen right now. Take care, stay safe, and goodbye.